Hi, Mick McQuaid here, welcoming you to the last video for day 3. This is a video in which we will concentrate exclusively on exercise 2.4.9. This is not an exercise to turn in. This is simply a dry run for tomorrow's exercise, which is to turn in. The idea is to help you format it properly and get the maximum possible points for the one that you're going to turn in tomorrow. Okay, and here it is, exercise 2.4.9. And in order to accomplish this, in order to do this, I'm going to point out that I have a set of exercise homework instructions that I'd like you to follow. And so I'm going to follow them here. So the first thing that it tells me in the exercise instructions is that I need to copy and paste this into a text file in a full-featured text editor. So I'm going to copy this. And here I have a full-featured text editor. I also have a copy of R here running. And I have to put a, I'm going to actually I might as well do this right now. Oops. Put a blank line between each one of these. Oh, maybe I should wait. Let me undo that. I didn't think this thing through carefully. Okay, so I'm going to for all the lines, I'm going to substitute for the beginning. I'm going to substitute that. I think that should do it. Yeah. Okay. So I put comment characters in front of all of these. So this is in a file called 0.r. Your file for tomorrow's homework is going to be called letter I, lowercase, .r, also lowercase. And you're going to copy the instructions for that exercise in, and you're going to include, let me get rid of these. You're going to include the instructions for the homework and then interleave your answers in between those instructions. Okay, so, and then at the beginning of the file, you're going to say the exercise number from the book, which is in this case 2.4.9, your name, and do it in the way that you like to be called. Don't worry about me being able to identify you from your name. Put the way that you like your name to be remembered. I only ever remember students' first names. I just don't have the ability to remember your last name, but I can pretty easily memorize your first names. And so put down the first name the way that you'd like to be called. I can always identify you via my courses. Okay, so having done that, then I'm going to start putting in my answers, and I'm going to leave a blank line in between these comments and my answers. And I have two types of things that I'm going to put in my answers. R code, which is going to be flush left with no hash marks as comment characters. And then my comments, or the things that it asks me, like which of the predictors are quantitative, things like that. And I'll precede those with 2 hash marks. Okay, so now the exercise involves the auto data set. Make sure the missing values have been removed. I'm completely unprepared here. I'm not on the network. Let me establish a network connection, because what I want to do is show you how I get this data set. And I'll okay, I guess I'm on. Am I on the network now? Yes, I'm on the network now. Okay, so what I'm going to do is open up a browser to get the data set. So let's see where this browser window will open, if it will be on screen or off. Okay, so it's off screen here. So I'm going to put it on screen. And what I'm going to do is Google, what shall I Google? ISLR auto.data. And it's going to be the case that the very first thing or one of the very first things that comes up is the website for this book. And one of the things that's on this very first page is auto.data. I'm actually, instead of auto.data, I've already looked at all these files, and this particular version of it is not very good. This is a much better version, so I'm going to get this version. So I'm going to download it, save it, make a note of where I've saved it, and then move it. Actually, I'm not going to do that because I did it already. Move it to the directory where I'm working. Okay, so that's a part of the work that I've already done before this. So I actually have a copy of a file called auto.csv in my current directory. So in order to bring that into R, I'm going to write a command like this. And don't worry if you don't understand this command yet, because I will explain. Okay, so this is an assignment operator in R, and so I'm assigning, this object is the recipient of the assignment. I'm going to create an object called auto, and I create it using the read function and the CSV method of the read function. And the first argument by default for that, an argument I don't have to name, is the name of the file, and that's in my current directory, so I don't need to qualify the name at all. I can just say auto.csv. That, I happen to know that that has a header in it. I could examine the file separately, but I'm not going to bother with that right now. I'm just going to tell you that I know there's a header in it, so I'm going to say header equals true. Capital T is an abbreviation for an acceptable abbreviation for true to R. Another parameter that I'm going to pass is NA strings equals quotation question mark, and that simply means that for any information in the file that's not available, whoever made the file up put a question mark instead of the missing value. So missing value is equal question mark. So this simply alerts R to how this is encoded. And then once I have it in, I'm going to alter it. Once I have it in R, I'm going to change it. So I'm going to say na.omit auto, and that's going to remove all the lines that have some missing values because I just don't want to use those lines. And then I'm going to check the number of rows in my resulting data set. Oops, what am I saying? I'm not creating an object. That's a function. nRow is a function, the number of rows. And then I also want to check the number of columns. And let's see, I'll also check the column names. Notice that I'm using a syntax highlighting editor, and when I spelled the name of the function wrong, it wouldn't change the color of it. And then I'm going to attach it so that I can refer to the column names without having to qualify them. Oh, and I'm also going to, it seems like I'm doing so much stuff before we get started here. I'm also going to say cylinders are a factor, not a numerical. I'm going to use them as a factor with levels rather than just using them as a raw number. So I'm going to do all these things, and what you're going to see here is in the left side of my screen I have R running. I'm simply going to press a keystroke that's going to pass these commands over to R. And that's a little bit simpler from my standpoint than actually typing the things into R and then cutting and pasting them into a text editor. Okay, so I have the expected number of rows, which is 392, and I have the expected number of columns, yay. And here are the column names that I have. Oh, and I don't, you know what, I don't really like the way that this looks, so I'm going to say, what am I going to say? Options width equals 50. Let's see if that looks a little bit better. Oh, that wasn't what I meant to do. There we go. Yeah, so that's what I want. I wanted that to look a little bit better. Let me put options in front of that. Okay, so that just tells the terminal how many columns wide the display is, so it narrows the display so it's easier for me to read. I can't read across that well. I have terrible eyesight. Okay, so now I've attached auto, and that lets me use these names, so I can now say cylinders instead of having to say auto $ cylinders. So I'm going to make that a factor. And now what's the next thing I'm going to do? Which of the predictors are quantitative and which are qualitative? So how am I going to know that? How can I figure that out? Well, one way that I can figure that out is to say summary auto. And if I do that, what I'm going to get is summaries of all the items in here. Now, I can tell immediately from this that name is a qualitative variable. I can't really tell that about origin, but I believe origin is a qualitative variable. Origin is the country of origin coded as 1, 2, or 3, and I think 1 means North America, which, come to think of it, isn't a country. 2 is the European Union, which is also not a country, and 3 is Asia. So it's not country of origin, it's, I guess, continent of origin or something like that. Miles per gallon, that's numerical. Cylinders we've changed to a factor, so I'm going to say that the qualitative, which are quantitative, are everything except, I guess, everything except cylinders, origin, and name. Okay, so quantitative is mpg, displacement, horsepower, weight, acceleration, which I can't seem to spell, and year. And then qualitative is cylinders, origin, name. And this may not actually agree with the textbook. The textbook may claim that 2 of these are actually numerical. They may claim that cylinders and origin are numerical because we can place them in order, but we're not going to. So that's my opinion, is that they're this way. Okay, what is the range of each quantitative variable predictor? You can answer this by using the range function. And indeed, we could say range mpg. So that's one way to do it. That's going to give us the range of miles per gallon. Miles per gallon ranges from 9 to 46. We can also do that by looking in summary, and we can see that the min in summary is 9 and the max is 46.6. So we could do this for all of them. I could list them all out like this, and it would be incredibly boring. Want to do another one? What's the next one? Displacement. Okay, 68 to 455, which agrees with what we already know. This is really kind of boring to do, though. So let's do it a different way. Let's use a function, an R function called sapply, that applies a function to a bunch of vectors. And the vectors we're going to hand it are auto. And this isn't going to work right away, so don't get too excited. It's going to fail, and I'll explain why in a second. Okay, so we've gotten a message here that says that range is not meaningful for factors. So remember that we converted cylinder to a factor. So that's a problem. So what we're going to do is get rid of factor as a column being considered here. So I want to get rid of, did I say cylinders? That's what I meant to say anyway. So I want to only consider column 1 and columns 3 through 3, 4, 5, 6, 7. So I'm not going to consider origin or name. Even though origin hasn't been declared as a factor, so consequently origin, as far as R knows, origin is a number. Okay, so what I've done here is index, which we're going to talk about tomorrow. I've indexed this data set so that only a portion of the data set is being passed to the sapply function. And having done that, I get this result, which is the ranges just for the desired items. So isn't that nice? So now I can do the same exact thing for the next question. So I'm just going to copy and paste this. What is the mean and standard deviation? So I can do this with mean. And I get the mean there. And I can do it for standard deviation. So let me just go over here and change mean to standard deviation. And that's really swell, isn't it? Now there is another thing that I can do. Let's see. Yeah, here's a real fancy thing that I can do. So this is pretty cool. So I'm going to type this in separately. this is really long. I'm going to wrap everything in a data frame, and I'm going to transpose my results, and then I'm going to give this sapply thing here with auto all rows, columns 1 to 1 plus 3 to 7, and I'm going to say function, and now I'm just going to say a placeholder name for the function, so I'm just going to say blah is my usual placeholder. And now I need to create a list of the actual functions. So I'm going to say means, which is mean, blah, SDs, which is SD, blah. Did I put a comma? Okay, yeah, I did. All right, good. Ranges. Quite a bit of what's hard about computing is typing. And one thing that I've noticed, God, how many parentheses am I going to need? See what I have a parenthesis matching thing here, so I was waiting until I had enough parentheses so that a parenthesis would match that very first one there. Okay, so this should give me a nice looking little table, and it does, of means, SDs, and ranges for the six quantitative variables. Okay, and this is not something that you should have been able to figure out on your own. And this is part of the R toolbox that I'm just showing you, like just junk that you can do that you might not know about, that you might not think of. R is a very powerful language, and there are a lot of things that we can do quickly that you might instead do slowly. But as you gain experience, you should learn little tricks like this. And tricks like this will become less opaque over time. Okay, now remove the 10th through 85th observations. What is the range, mean, and standard deviation of each predictor? Okay, so what we can do, we can copy this stuff in the subset that remain. So we can copy all of these things, and we just have to alter them a tiny bit. So I can alter these things a tiny bit. So what I want to do is omit rows 10 through 85. So the easy way to do that is to put in a row specification here. And so that row specification is going to be, minus 10 colon minus 85. And I should point out that I did not need to wrap these in this C and parentheses because they are contiguous. If they were not contiguous, if there were a comma in them, then I would have needed to do it this way. But since there isn't, I can just do it like this. Okay, and what I'm going to get, I can either use this method, which is 3 commands, or use this table method, which is 1 command. And what you'll notice if you look up here at this version is that the ranges are narrower than they were before. And that is as it should be because we've taken a subset. So obviously the subset's going to have either the same ranges or narrower ranges. If we had wider ranges here than what we have here, then we would know that something was wrong. And you should always be checking your work. You should always be looking for common sense things that tell you that something is wrong. And so I glance at these things from time to time and try to see if I see anything that looks suspicious to me, and I don't see anything that looks suspicious here. Okay, using the full data set, so we're going to go back to the full data set here. So it's a good thing we didn't actually eliminate these. It's a good thing that we simply said, don't use these. So we still have the full data set. So using the full data set, investigate the predictors graphically using scatter plots or other tools of your choice. Create some plots highlighting the relationships among the predictors. Comment on your findings. Okay, so I'm only going to do a couple of plots here. The main one I'm going to do is called pairs. This is a scatter plot. This will produce a scatter plot matrix. We can also say SPLOM, I think, although I might need to load a particular library to say SPLOM. And here's the output of it. Now this output is ridiculously compressed so that it will fit onto this screen, and I can compress it even more. But I'm going to expand it, so now we're only going to be able to see the upper corner of it, but you'll have a much better view of it. Okay, and I can sort of move it along the display here. So this is a scatter plot matrix. This is a matrix that shows along the main diagonal every single variable name. And it shows in the spaces where the variable names meet, it shows a scatter plot of those two variables. So this is a scatter plot of miles per gallon versus cylinders. And if you'll notice, this is a flipped version of that exact same plot. These are the same. These two are the same. These two are the same, and so on, all the way down. So you really only need to look at half of a scatter plot matrix. And in fact, if you learn much more about R, you'll learn of ways of using this extra space down here for some other stuff. Or using this space here instead of putting the names here, put other stuff instead of the names here. So my favorite way to begin looking at a data set is to do a scatter plot matrix. So this is my favorite graphical command for starting out. It's very easy, it's very simple, and it tells me right away where there are some relationships. I can see, for example, all these very linear looking relationships and all these very curvilinear looking relationships here. So this is quite valuable, and I can tell these are categorical variables right away because of the lines. And there's another categorical variable there. That's year. Well, that's a variable that perhaps should be categorical because they're only. Oh no, there are a bunch of values of year. I take it back. No, that's just again showing that cylinders is categorical. Okay, and then another thing that I could do. So I'm going to squeeze this into the upper corner here, and I'm just going to plot two of them. So if it's too hard to view this, we can say, for example, plot displacement by horsepower. So this is just two of the variables, and we get a more readable plot. So I could do that with all of them to get better scatter plots. And then there are a vast number of plots that I could do. But what I can tell from just looking at the scatter plot matrix is the following. Oops. The strongest linear relationship is between displacement. And usually with statistics, we like to weasel word things. So usually I would say more like the strongest linear relationship seems to be between displacement and horsepower. The next strongest linear relationship seems to be between displacement and weight. I'm just copying down from some. I looked at this earlier because I didn't want to have, well, I do have long pauses in here, but I didn't want to have too many long pauses in here. And horsepower and weight. There's a strong categorical relationship between displacement and cylinders. There is a somewhat strong categorical relationship between displacement and origin. There are strong linear relationships between miles per gallon and displacement. Let me just fix that typo here. What else? Between miles per gallon and displacement, I already said miles per gallon and horsepower. Those were those three at the top. And miles per gallon and weight. It's the three at the top on the top row of the when we were looking at the scatter plot matrix made by pairs. The other relationships are less clear. Okay, suppose that we wish to predict gas mileage on the basis of the other variables. Do your plot suggest any of the other variables might be useful in predicting miles per gallon? Here again is something where I don't need to run any R commands, or I shouldn't say again, I guess this is the first one where I'm not going to run any R commands. I'm just going to use my scatter plot matrix as the basis for answering this question here. So let me leave a blank line there, put my two hash marks, and say weight appears. And this again is, I just went back and looked at my scatter plot matrix. It might actually be better for you to, if you have a big enough screen, you won't have any problems doing the scatter plot matrix. My whole screen is quite a bit larger than what I'm showing you, so it's pretty easy. You may need to print out, or if you have a low resolution screen, or do individual scatter plots. Shows that only, let's see, two 3,500 pound plus cars get better than 20 miles per gallon, while no 40 mile per gallon car. This is really old data. Cars have come a long way since this was made up. You can't really save that much money by getting an old car these days because newer cars are so much better and they last so much longer. Unless you just love old cars. I have had a couple of old cars just because I love them. But I'm under no illusions. It's not a way of saving money. It's just, it's something that really, some old cars are just beautiful and interesting. But they are expensive compared to new cars. And I'm putting this amount of detail in here. You don't have to be too detailed. And I do hate really, wasteful, irrelevant stuff that people stick in just to try to get points. If I suspect that you're sticking in a bunch, that you're just saying every possible thing that could be said, hoping that something turns out to be right, I will take off points for that. And I will tell you in the comments section in my courses that you went too far. So you have to develop an intuition for being concise, and that's something that students often don't have. Okay, so that's pretty much the end of it. That's the whole. That's all there is to this assignment. So I'm looking forward to talking to you again tomorrow, and I thank you for your attention.